Okay, parabolas. This is how parabolas are defined. On your sheet, you can see the definition, but it says a parabola is a set of points in a plane equidistant from a fixed point, the focus, and a line called the directrix. So a focus is a point, and remember, the focus, whatever curve we're looking at, is always enclosed by the curve. So you are familiar with parabolas because you saw them in college algebra. They're U-shaped graphs. So this is a parabola, one that I've drawn. The focus is enclosed, and on the outside, the directrix is not part of the parabola, but it helps define it. Much like a center and a focus is not part of the graph, but it helps define it. So every point on this parabola, wherever we can find, so I just chose this point, the distance from the focus to this point and the distance from the directrix to this point is equidistant. It's the same distance. And so that's true at this point, at the vertex right here, same distance. At this point, same distance from here to here, and everywhere. Any point that you can find on the parabola, that's going to be true, and that's how it's defined. So let's just talk about the parabolas that we've known in the past in college algebra. Y equals to x squared is a basic graph we've already talked about in this class. Y is equal to a times x minus h squared plus k is the vertex form of a parabola, and you saw that in college algebra. These are functions. So these parabolas face up and down. We will be seeing these same parabolas that face up and down, but we're gonna put it in a different format a little bit. Also, we will be discussing sideways parabolas that are not functions, right? So if these parabolas face up and down, because they're functions and they pass the vertical line test, okay, we are also going to be discussing parabolas that face left and right. These are not functions, and they look a little bit different. The applications of parabolas have to do with satellites or, what are we trying to think of? The, not microphones. Is it microphones? You know, the big, at football games, they have the big dishes for the to pick up sound, receivers for that. Antennas are applications. Flashlights are applications. I have put a document in, the modules before each of these so that you could see applications of each of these. And then in a little while, we'll be talking about how to apply these. But so they don't just have to face up and down. They can face anywhere we need them to in order to shine our light or pick up sound or whatever it is that we need to do. So let's discuss the forms of parabolas in the way we're looking at these in terms of conic sections. Okay, so I put the picture of how this conic section is. If you've got a cone and it's sliced by a plane and it cuts through at an angle through the end of the cone, it leaves that shape right there. And if you go back to the video on circles where I introduced them, you can see where I tried to do that with party hats. So anyway, let's see. Example 1 says identify, oh wait, before we do that, let me talk about the different forms. So these are the equations that you might see. X squared is equal to 4CY. Okay. This one is the one that you have known a long time in your math life. This is the function. It phases up and down. The vertex is at 0, 0. We don't see any minus h or minus k. And this one will face up, or it will face down. And if C is positive, it faces up, or if C is negative, it faces down. Okay. This is when the vertex is at hk, then it looks like this. X minus h squared is equal to 4c times y minus k. So what is new here is this little value c, which helps us figure out the focus. Okay, the focus is c, okay? It's c units, 0 c is what it would be, the coordinates of that focus. C is the distance to the focus from the vertex. This is the vertex right here. Okay, so it doesn't have vertices, it just has one vertex. Okay, so what about the case where it's sideways? That we haven't seen much before. This is the equation of that. Instead of x squared, we have y squared is equal to 4cx, or y minus k squared is equal to 4c times x minus h. Here the vertex is at hk. Here the vertex is at 0, 0. In this case, if c is positive, it faces to the right. If c is negative, it faces to the left. Okay, so now those are the basic forms of our parabolas. So let us go ahead and start with number 1. Number 1 says, the directrix is a line outside. So in this case, let me just draw it. In this case, if it's facing up and down, this directrix will have y equals to negative c is his equation. If we had a parabola facing this way, and we say this is the focus at c, 0, this is the vertex at 0, 0, the directrix would be back here. It would be this vertical line, x is equal to negative c in that instance. Okay, number 1. They tell us that x squared is equal to 4y. And so they want us to identify a few things. Identify the vertex, the focus, and the equation of the directrix. Okay, so number 1, part A, is x squared is equal to 4y. Okay, the vertex is at 0, 0. I can see that right off the bat because I don't see any minus h or k going on. So this is the vertex, 0, 0. Now, x squared, this is how I put this in my head. X squared is the one that I've seen my whole life up until this point in my math life. And so this is the function. So it faces up or down. This will face, this is going to face up or down. It's going to face up because I don't see a negative here. So it's going to be facing up. That's what I know. Identify the vertex, the focus, and the equation of the directrix. Okay, the focus is going to lie somewhere in here. So let's see. This is going to be on the origin. This is the vertex. The focus is going to lie there. So I have to figure out what c is. This formula is x squared is equal to 4cy. So whatever I see here, which in this case is just a 4, is equal to 4c. So I solve for c. I divide both sides by 4 and I get c is equal to 1. That means the focus is 1 unit up. So the focus is at 0, 1. And that means the directrix is 1 unit on the opposite outside. So the directrix is down here. 1 unit down right here. Y equals to negative 1. This is the directrix. All right, so that's 1A. Let's go again. Let's look at B. B is y squared is equal to negative 1 over 32 times x. So this is this form. So again, the vertex is at 0, 0. Okay. And so I need to figure out this. There's a negative involved, and so that means it's going to be facing to the left. Okay. So maybe I'll draw it a little bit bigger this time. It's going to be facing to the left somehow. Okay. What is the value of c? Well, 4c is equal to whatever I find next to this x. Okay. 4c is equal to negative 1 over 32. Okay, so I divide both sides by 4 to figure out what c is going to equal to. So c is equal to 1 divided by over 32 divided by 4 is negative 1 over, wow, that's going to be really small, isn't it? 1 over divided by 4. 1 over 32 divided by 4 over 1 is negative 1 over 32 times 1 over 4 is negative 1 over, wow, what is that? 8. Negative 1 over 128. So let me just make sure I haven't made a mistake here. Okay, so that was correct. That was correct. Negative 1 over 128, it just was such a tiny number. So it's right here is the focus. So the focus is at 0, negative 1 over 128. Nope. Coordinates, I got this backwards. So the focus is at negative 1 over 128, 0. The vertex is at 0, 0. And so the directrix is going to be on the outside. It's going to be a vertical line right here, and the coordinates are going to be x is equal to 1 over 128. All right. Part C is x squared is equal to 1 over 9y. Again, the vertex is at 0, 0 because we do not see a minus h or k. This is our function. It's going to be facing up or down. It will be up because this is positive. So let's just kind of draw it. Here is our vertex is at 0, 0. 4 times c is equal to whatever number is there. So that's equal to 1/9. Divide both sides by 4, we get 1 over 36 is what c is. So that means the focus always lies inside the graph. It's going to be here, f. This is my vertex, and then my direction is outside the graph. So y is equal to negative 1 over 36 is the equation of the directrix. The vertex is 0, 0, and the focus is at 0, 1 over 36. So that's number 1. Okay, let's go on and look at number 2. Number 2 says sketch each parabola, identify the vertex, focus, the domain, and range. So we already sketched some of these, so this shouldn't be too hard. Let's get it going. This is number 2. So I'm going to just erase this so I have more room. All right. Number 2, part A says y is equal to x minus 5 squared minus 4. Okay. Y is equal to x minus 5 squared minus 4. Okay. So let me just remember, what are my basic forms? It's either y squared is equal to 4cx or x squared is equal to 4cy. Okay, and then if I add in the x and k, h and k, it would be x minus h squared is 4c times y minus k. This would be y minus k squared is equal to 4c times x minus h. Okay, so what's important here is when they give you a jumbled up thing, get it in a good form before you start. So the good form in this context is to isolate the squared term. Notice there's only one thing squared. This is how I know it's a parabola. In the other equations, we've had two things squared. Circle, two things squared, ellipse, and then two things squared later will maybe a hyperbola. But these parabolas are so easy, only one thing squared. So x is being squared. I want to get it by itself on one side of the equation. So I'm going to add 4 to both sides. Okay, so this is what happens when you isolate the x squared. I wanted it on the left just because that's what I'm comfortable with. And I'm going to compare it with this. So h is 5 and k is negative 4. So my vertex is at 5, negative 4. This is the form I compare with. Now I want to find the value of c. So 4 times c is going to be whatever's outside of this term. And so that's a 1, because I don't see anything, that's a 1. So I say 4c is equal to 1, so c is equal to 1/4. I solve for c. Now I have basically everything that I need to sketch this guy. So let's do that. Here is, I'm over here at 5, negative 4, 1, 2, 3, 4, 5, 1, 2, 3, 4. Here I am. That's my vertex. This is a positive c. X squared means it's facing up or down. These are the up or downs, right? C is positive, C is negative. These are the left or right. This is C is positive, this is C is negative. Okay, so C is positive, it's going to be facing up. So that means the focus is going to be inside the curve. So from this vertex, which is 5, negative 4, the focus will lie inside. So it's going to be right here is the focus, okay? And you don't have to have it in the exact right shape. You just have to have it facing the right direction. The focus has the coordinates 5 and it went up 1/4. -4 plus 1/4. Okay. And what else did they ask me for? They wanted, they didn't ask for the directors this time. They wanted the vertex, the focus, the domain, and range. So the domain is the x's. -infinity to +infinity. The range are the y's. The lowest point is -4 and the highest point is infinity, just like that. All right, let's do B. B is x is equal to y plus 2 squared minus 1. Again, I want it to be something I recognize, and in this context of conic sections, something squared, isolate that. So what's being squared? The y plus 2 is being squared. So get him by himself by adding 1 to both sides. So we'll add 1 to both sides. X plus 1 is y plus 2 squared. And I like the something squared on the left because this is how I've gotten used to seeing these formulas. So I'm going to put y plus 2 squared is equal to x plus 1. I just flip-flop those. Okay, that's fine. Now, I recognize if y is being squared, this is not my function. This is a left-right, either left or right. I don't see any negative, so I know it's opening to the right. I know that this is going to be it's going to open to the right. I know the focus is going to be there, and the director is going to be there, and the vertex is going to be there somehow. Where is the vertex? The vertex is at h, -1, okay, -2. Okay, so how can I figure out the value of C? Well, C, for C, is equal to whatever I see in front of this. And again, it's a 1. So, for C is 1, so C is 1/4. All right, so let's sketch this guy officially. Go to -1, -2, and put your vertex. We know he's opening to the right. The focus is right here. It's not very far away. Draw yourself some parabola shape. They didn't ask me for the directrix, but I could draw it if I needed to. They asked me to identify the vertex and the focus. Okay, the focus, his coordinates will be, this is -1, and then I went to the right 1/4. So it's -1 plus 1/4, which is going to be -3/4. I guess if I want over here, where did I do this? -4 plus 1/4, this would be -16 over 4 plus 1/4. I could go ahead and make this. This was okay what I had written. It's okay with me. Or -15 over 4 is what that would be if you wanted to write it like that. Okay, so there's a -3/4, comma, -2. Vertex, focus, what else? Domain and range. The domain, no x, no x, no x, x right here. So it starts with this vertex, which is at -1, 2. Okay, so the domain is, we don't see anything until we get to x is -1, and then it goes on forever. The range is eventually as low or eventually as high as we want to go, from -infinity to +infinity. So that's all I'm going to put on this video. I will finish up the rest of these problems in the next upcoming video.